Hello, in the final project, we try to implement the NYU6463 processor, and this is the basic graph given by the guideline, and I keep all of these parts because they are all useful to implement all the instructions. But based on this, we need to add more modules to it, like a divider, because we need to implement the divide instruction. So in this case, this is the divider we implement in the midterm exam, and it takes the denominator, numerator, and the valid signal as inputs, and outputs the quotient and remainder, and the ready signal. And these signals will be taken from the decode unit, or give the signals to the decode unit. And so here's the code for decode unit. We add some more signals to it, like this jump source. It's used to select the jump addresses or branch addresses. And this halt signal is to halt the PC to stop the program counter to update. And we use this when we meet the halt instruction or when we do the division, because we need 32 clock cycles to finish the division operation. And this source is a mux to select the ARU result and the divider result. And this signal is used to reset the divider when we finish the division. And we do some more logics on divider, like when we start the divider, we need to halt the PC, and when we finish, we need to reset and make the halt to be 0. So let's see the final schematic. Now here's the schematic. You can see, you can almost see all of the parts in the basic graph, and we have the divider here, and also we have one more mux jump source to select the branch address and the jump address. And now we try to test the function of our processor. And at the very beginning, we try to test all of the instructions, and these almost include all of the instructions, but I just test the BQ because the other two BLT and BNE are very similar to BQ. We initialize the register file to be 0 to 0, 1 to 1, 2 to 2, etc. And the brackets shows the calculated results. And let's see the simulation results. Run the simulation. The instructions are implemented in this file in the initial begin end, and the test ends at PC equals to 56. And let's see the simulation results. And turn this radix. Let's see, we end at 56, and this is 60. So let's check the results. We changed the value of the register from 6 to 13 and 30 and 31. they should be the same as calculated results here. And then we try to test one simple program. The program here is implemented in C language. It's very simple. We have an array which is implemented by data memory. We have a for loop. We called function called test. The test I. If I is greater than or equal to 5, we return I divided by 2. Else we return I modulo 2. And here's this assembly code. And we have the loop condition which judge the I and 10, and we have start which initialize I, and body we store the result into array which is data memory. And also the test function, we do division, and this is if BLT is for if else. And in this case, because jump instruction can only jump backwards, so we need to do some ordered those labels for branch instructions. And let's see the results. The assembly codes are implemented here. It's to PC equals to 128. You can check this in detail. And then let's see the results. In this case, it's halt this PC. So the results can be shown here. This is for data memory. We have 0101 02 3344, which should be the same as the results for these two divided by 2 and modulo 2. Now you can check this in detail. That's the end. Thank you.